Discovering a young gas giant. Insights from MP Mus Protoplanetary disk. **** The hidden world of protoplanetary disks. Unveiling the secrets of MP Mus ***. Imagine a cosmic dance, where planets and stars are born from a swirling disk of gas and dust. This is the realm of protoplanetary disks, and one system, MP Mus, has long been an enigma. Now, a groundbreaking discovery is set to revolutionize our understanding of these disks and the planets that form within them. ***The puzzle of MP Mus ***. For years, astronomers have been baffled by MP Mus, a protoplanetary disk that appears structureless, defying the norm of its peers. The disk's smooth appearance, particularly at millimeter wavelengths, has sparked intense debate. Is it truly featureless, or are there hidden substructures waiting to be uncovered? ***, a new perspective. The power of longer wavelengths ***. A team of scientists has taken a fresh approach, observing MP Mus at a longer wavelength, 3 millimeters, with the Atacama Large Millimeter or Submillimeter Array, ALMA. This innovative strategy has revealed a stunning inner cavity, a ring, and 2 gaps, previously undetected at shorter wavelengths. The findings suggest that MP Mus is, in fact, structured, challenging our current understanding of protoplanetary disks. ***, the Gaia connection. Unraveling the mystery of MP Mus ***. But here's where it gets even more intriguing. The Gaia spacecraft has detected a significant proper motion anomaly in MP Mus, hinting at the presence of a companion. By combining the ALMA observations with Gaia data, the researchers have pinpointed the location of this companion to the inner 1 to 3 astronomical units, AU, of the system. ***, simulations confirm the suspicions ***. Hydrodynamic simulations using the phantom code have validated the existence of a gas giant planet within the inferred orbital range. The simulations demonstrate that a planet at 1 to 2 AU can carve a cavity consistent with the observed features, further solidifying the case for MP Mus B. ***, implications and controversies ***. The discovery of MP Mus B raises essential questions. 1. Planet formation theories ***. How do planets form in the inner regions of protoplanetary disks, and what role do they play in shaping the disk structure? 2. Disk longevity ***. Why do some disks, like MP Mus, survive for millions of years, while others dissipate more quickly? 3. The prevalence of hidden substructures ***. Are there more disks like MP Mus, with concealed substructures waiting to be uncovered? Join the discussion ***. We invite you to share your thoughts on these questions and the implications of this groundbreaking discovery. Do you think MP Mus B is an outlier, or is it a harbinger of a more complex reality in protoplanetary disks? References Kepler et al., 2018. Discovery of a planetary mass companion within the gap of the transition disk around PDS 70. Haffett et al., 2019. 2 accreting protoplanets around the young star PDS 70. Barber et al., 2024. A giant planet transiting a 3 MYR protostar with a misaligned disk. Explore further the disk substructures at High Angular Resolution Project, DSHUP. The sphere view of the Taurus star-forming region. The sphere view of the Chameleon Eye star-forming region. Data availability All data used in this work are publicly available through the ALMA archive, programs 2022.1.01758.s and 2017.1.01167.s, and the Gaia archive. Discovering a newborn planet. Insights into Earth's formation. The discovery of a newborn planet offers insight into Earth's formation. Imagine catching a glimpse of our planet as it was 4.5 billion years ago. Astronomers have made a groundbreaking discovery by observing a newborn planet in its formative stages, nestled within a swirling disk of dust for the very first time. Francesco Maio, a researcher from the University of Florence in Italy, expressed the excitement of this finding. While we will never be able to witness the formation of Earth itself, we might just be observing the birth of a planet in real time, located around a young star 440 light-years away. Utilizing the European Southern Observatory's Very Large Telescope situated in Chile, astronomers focused their attention on a young star known as HD 135344b. Are we on the brink of discovering extraterrestrial life in this golden age of space exploration? https://www.thetime.com/uk/slash/article/were-dash-and-dash-golden-age-of-5-7 Surrounding this star, they identified a disk of dust that radiated outward in spiral arms, reminiscent of the Milky Way's structure. At the core of one of these spirals, they discovered a protoplanet, a collection of rocks and dust that has begun to merge into a planet. This protoplanet is estimated to be twice the size of Jupiter and is located at a distance from its star comparable to that of Neptune from the Sun, roughly 30 times the distance between Earth and the Sun. While such dust disks have been observed around other stars, astronomers have long speculated that the spiral patterns, rings, or gaps within them were indicative of forming planets. However, this is the first time they have witnessed an infant planet actively shaping the dust around it. Maio, who led the research published in the journal Astronomy and Astrophysics, noted, what makes this detection potentially revolutionary is that, unlike many earlier observations, we can directly identify the signal from the protoplanet, which remains deeply embedded in the disk. This significantly boosts our confidence in the planet's existence, as we are observing the light emitted by the planet itself. Have astronomers unraveled the mystery behind the cosmic Morse code signal? https://www.thetime.com/uk/science/article/Morse-code-signal-dash-9B5HX99QB. In a separate study released on Monday, astronomers have also unveiled that one of the most renowned stars in our night sky, Betelgeuse, located in the Orion constellation, has a faint companion star orbiting it. This discovery may finally clarify a long-standing enigma regarding the fluctuations in Betelgeuse's brightness. For this investigation, astronomers employed an instrument called ALMA on the Gemini North Telescope in Hawaii. https://www.thetimes.com/topic/Hawaii, to scrutinize Betelgeuse, which is among the brightest stars visible from Earth. Betelgeuse, a red supergiant star in the Orion constellation, is believed to be nearing the end of its life cycle. Jicker_Skomroker, Getty Images. At just 10 million years old, merely 1/450th of the age of our Sun, Betelgeuse is thought to be in its red supergiant phase, suggesting it could explode in a spectacular supernova within the next few tens of thousands of years. For centuries, astronomers have observed that Betelgeuse's brightness varies in a regular pattern, leading some to propose that a second, much dimmer star might be orbiting it, periodically obscuring some of Betelgeuse's light. This elusive companion star has now been detected by researchers at NASA's Ames Research Center, under the leadership of Steve Howell. Their findings, published in the astrophysical journal Letters, indicate that this companion star has a mass approximately 1.5 times that of our Sun, yet it is significantly dimmer than Betelgeuse. It is likely spiraling inward, with the potential to collide with Betelgeuse in a fiery end within the next 10,000 years. Howell remarked, previous studies predicting the existence of Betelgeuse's companion suggested that imaging it would be nearly impossible. What do you think about these discoveries? Are we on the verge of understanding more about our universe, or do you believe there are still many mysteries left to uncover? Share your thoughts in the comments below. Witness the birth of a new planet. Astronomers discover a protoplanet sculpting the dust around it. Imagine being able to witness the birth of a new planet, a process that's been shrouded in mystery for centuries. Astronomers have long been fascinated by the formation of planets, and now they may have caught a glimpse of a still-forming planet in action, carving out an intricate pattern in the gas and dust surrounding its young host star. This groundbreaking discovery was made possible by the European Southern Observatory's ESO, Very Large Telescope, VLT, which observed a planetary disk with prominent spiral arms, finding clear signs of a planet nestled in its inner regions. But here's where it gets even more fascinating. This is the first time astronomers have detected a planet candidate embedded inside a disk spiral. According to Francesco Maio, a doctoral researcher at the University of Florence, Italy, and lead author of the study, we will never witness the formation of Earth, but here, around a young star 440 light-years away, we may be watching a planet come into existence in real time. The potential planet in the making was detected around the star HD 135344b, within a disk of gas and dust called a protoplanetary disk. The budding planet is estimated to be twice the size of Jupiter, and as far from its host star as Neptune is from the Sun. As it grows into a fully formed planet, it's shaping its surroundings within the protoplanetary disk. Protoplanetary disks have been observed around other young stars, often displaying intricate patterns such as rings, gaps, or spirals. Astronomers have long predicted that these structures are caused by baby planets, which sweep up material as they orbit around their parent star. However, until now, they had not caught one of these planetary sculptors in the act. The case of HD 135344b's disk is particularly interesting, with swirling spiral arms that had previously been detected by another team of astronomers using the SPHERE instrument on ESO's VLT. But none of the previous observations of this system found proof of a planet forming within the disk. Now, with observations from the new VLT's Enhanced Resolution Imager and Spectrograph (ERIS) instrument, the researchers say they may have found their prime suspect. The team spotted the planet candidate right at the base of one of the disk's spiral arms, exactly where theory had predicted they might find the planet responsible for carving such a pattern. What makes this detection potentially a turning point is that, unlike many previous observations, the researchers are able to directly detect the signal of the protoplanet, which is still highly embedded in the disk. This gives them a much higher level of confidence in the planet's existence, as they're observing the planet's own light. And this is the part most people miss. The fact that the planet is still embedded in the disk means that it's still in the process of forming, and astronomers can learn a great deal from observing this process. But here's the controversy. Some astronomers might argue that the detection of the planet candidate is not conclusive, and that further observations are needed to confirm its existence. Others might argue that the planet's formation is not as straightforward as it seems, and that there may be other factors at play. So, what do you think? Do you believe that the detection of the planet candidate is a major breakthrough, or do you think that further observations are needed to confirm its existence? Let us know in the comments. In a separate study, a different team of astronomers used the ERIS instrument to observe another star, V960 Mon, which is still in the very early stages of its life. The team found a companion object to this young star, which could either be a planet in formation or a brown dwarf, an object bigger than a planet that didn't gain enough mass to shine as a star. If confirmed, this companion object may be the first clear detection of a planet or brown dwarf forming by gravitational instability. The research highlighted in this release was presented in two papers, one published in Astronomy and Astrophysics and the other in the Astrophysical Journal Letters. The teams behind the studies are composed of astronomers from around the world, including the University of Florence, Italy, the European Southern Observatory, and the Diego Portales University in Chile. The Atacama Large Millimeter a Submillimeter Array, ALMA, an international astronomy facility, is a partnership of ESO, the U.S. National Science Foundation, NSF, and the National Institutes of Natural Sciences, NINS, of Japan in cooperation with the Republic of Chile. ALMA is funded by ESO on behalf of its member states, by NSF in cooperation with the National Research Council of Canada, NRC, and the National Science and Technology Council, NSTC, in Taiwan, and by NINS in cooperation with the Academia Sinica, AS, in Taiwan and the Career Astronomy and Space Science Institute, COSI. The European Southern Observatory, ESO, enables scientists worldwide to discover the secrets of the universe for the benefit of all. We design, build, and operate world-class observatories on the ground, which astronomers use to tackle exciting questions and spread the fascination of astronomy, and promote international collaboration for astronomy. Established as an intergovernmental organization in 1962, today ESO is supported by 16 member states, along with the host state of Chile and with Australia as a strategic partner. ESO's headquarters and its visitor center and planetarium, the ESO Supernova, are located close to Munich in Germany, while the Chilean Atacama Desert, a marvelous place with unique conditions to observe the sky, hosts our telescopes. ESO operates 3 observing sites, Larsiller, Paranal, and Chajnantor. At Paranal, ESO operates the Very Large Telescope and its Very Large Telescope Interferometer, as well as survey telescopes such as Vistor. Also at Paranal, ESO will host and operate the Churynkov Telescope Array South, the world's largest and most sensitive gamma-ray observatory. Together with international partners, ESO operates ALMA on Chajnantor, a facility that observes the skies in the millimeter and submillimeter range. At Cerro Armazones, near Paranal, we are building the world's biggest eye on the sky, ESO's extremely large telescope. From our offices in Santiago, Chile, we support our operations in the country and engage with Chilean partners and society. For more information, you can visit the ESO website or contact the ESO Media Manager, Barbara Ferreira. So, what do you think about these groundbreaking discoveries? Share your thoughts with us in the comments below.